A couple of you have asked me to solve this problem that was on the exam review, number 11b, which asks to use the precise definition of the limit to prove that as the limit of x approaches 2 of x squared plus 2x, that is equal to 8. So the idea is that we'll do a little bit of scratch work first, and then we'll write out the proof in the beginning. So what we want is that when we take the function and we subtract the limit, that this will be less than epsilon. But what we need to start with is x being close to 2, so x minus 2 being close to delta, and sort of work our way back up to the first inequality. So the question is always which delta will work, right? Epsilon is given to us and we have to figure out the delta. Okay, so let's simplify a little bit. So you might notice that this quadratic factors as x minus 2, x plus 4, okay? And with the absolute values, we can even separate this. Now, because x is approaching 2, if delta is small, in particular, if we choose delta to be at most 1, what we'll have is our x values that we're plugging in close to 2, right? So between 1 and 3, right, if delta is small. So in particular, x plus 4, whatever we're plugging in for x, will be between 5 and 7. Okay, and now this is great because we can use this bound here. Okay, so let's start over from the beginning. So this is what the proof will look like. I'll do it in a different color. Let's do green. Okay, so let epsilon be greater than 0 because that's given for us. We don't get to determine that. And then what we'll do is we'll say, okay, let then take delta to be the smaller of 1 because we definitely wanted it to be at most 1. And here, x plus 4, we know x plus 4 is going to be less than or equal to 7. Okay, so we can take the minimum of 1 and epsilon over 7. Okay, so that seems a little bit mysterious, but now consider x minus 2 less than this delta, which means in particular x minus 2 is less than epsilon over 7. And because x plus 4 is less than or equal to 7, what we can do is we can replace this with something smaller, which is x plus 4, right? And when we multiply that out, we get x squared plus 2x minus 8 less than epsilon, okay? Which is what we wanted in the first place. Now, where did we use the fact that delta had to be at most 1? Well, we used it in the fact that then x plus 4 is smaller than 7. So we used it in this step here. So you don't see it explicitly, but you wouldn't be able to make that leap if we didn't know that delta was smaller than 1. Because if delta was very large, like 100, then x plus 4 could also be very large, could be much larger than 7. Okay.